chance to go through this in as much detail as the other hour, so I'm going to just start from scratch here. Particle motion, we're looking at the relationship between position, velocity, and acceleration, and we're talking about the motion of a particle or the motion of an object. Just I call it particle, that's what it's called, but just think of it as an object. It can be a person walking, a person running, it can be a car moving. Now it's one-dimensional and it's in a horizontal straight line, so we're not talking about veering off to the left or right or going up or down or anything. It's direction, and it's just in a straight line, so you can only go left or right, okay, or go forward or back. There is no kind of veering off southwest kind of business, okay? It's just straight forward, straight back. That's it. That's all we do in Calc 1. Calc 2, you get into more multivariable calculus, you get into more multidimensional, and then you can start looking at it, motion along a curve. You can look at motion in a vector, in a vector direction. So that's not what we're looking at, though. So let's clarify. So what was the relationship between position, velocity, and acceleration? We said S of t is position, right?
Yeah.
We said the derivative of position is what? Velocity. And that's instantaneous velocity, not just any velocity. It's not average velocity, it's instantaneous. And then the second derivative of position is what? Is acceleration, or the first derivative of velocity. Now, one of the things that I want you to keep in mind here is we look at this, and before I even do the example, the two examples, I want to talk about a couple things. Position, what does velocity describe about position? So let's just look at a position graph for just a second. So here's a position graph, and I want to go through this in about every 10 minutes. Can you come over here and stir this? Yeah, just stir it in 10 minutes stir it. Something like 5, 10. So position, or 5 minutes, whatever. If I look at a position curve or a position graph, and you might want to write this down, might be a benefit. So if I have a position graph, and let's just go from 0 to, I don't know, let's go, position is measured in meters. And let's go by 5s on the y-axis, so this is 5, 10, 15, so down here would be -5, -10, -15, so on. And let's go in seconds on the x-axis.
Isn't that backwards?
What?
Sorry.
Is that good? All right, so let's go in seconds on the x-axis, this is time. And we're plotting out the positions of a particle in a straight line. And let me illustrate. Let's say the position at 0, it started at 5. And then it moves to a position of 10. Let's say it stays at a position of 10 up to 3 seconds. Then let's say it goes down to a position of 0, and then let's say it goes down to a position of -5, then -10, and back to 0. And let's say it stays on the x-axis here and then goes back to 5. So let's say it looks something like this. So there's a position graph. Okay? Now, if I was to describe, what is this describing? It's describing motion in a horizontal line. So when you look at this, what you're saying then is at 0 seconds on a number line, 0, let's just go by 5s here too. 5, 10, 15. Is there hot dogs?
Yeah.
Yes. Put them in one of the buckets. Put them in one of the crock pots. Put them in one of the back ones. There's like scissors in my hot dog drawer over there. Okay? So what this describes then is at 0 seconds. Watch this. Don't focus on them. Okay? I know it's goodness over there, but at 0 seconds, we're at a position of 5. So watch the particle. It starts here at t equals 0. So here it is at t equals 0. It's at 5. Then what does it do? Oh, it goes to the right. Very good. Okay, it goes to the right. And how far does it go? It goes to where? 10. When does it get to 10? T equals 1 second. Now it's at 10. What does it do now? Stays at 10 till how long?
T equals 3.
2, t equals 3. Then what does it do? Turns around and goes where? Left
T equals 0.
to 0, and it gets there when? at 4 seconds. Now what does it do?
Keeps going.
Then it keeps going left all the way to negative 10. And that's at t equals 6. Now what does it do? Turns back around. Goes back to 0. And that's at t equals what? And 2t equals 8. Then what does it do? Goes back to 5 or 10?
I don't know.
I think it's 5.
Yeah, we'll call it 5 down here. And it ends here at t equals 9. Do you see that that graph describes the position of this object? And I'm just going back and forth on a horizontal line. And this graph happens to describe that because I plotted out the positions where time is on the x-axis and position is on the y-axis. But what it's describing is the particle in a horizontal line. Now, do you make the relationship, okay? So once I get that, now here's the thing. What I hope you notice is that as I started at 5, okay, right here. Then I moved which direction? Look at the graph. I moved which direction? To the right. Then I moved what? Then I moved back what? Right. Now look at the graph. I moved right. What do you notice about the slopes? Positive slopes. Now, if the derivative of position is velocity, and the slopes are positive, what is that going to force your velocity to be? Your velocity is going to be what? Positive or negative?
Positive.
Which means the velocity is going to be what? Above the x-axis. Okay? So, when the position, watch this, position has positive slopes, the velocity is positive. It's above the x-axis. What's the position here? What's it doing? Is it moving right? Is it moving left?
No.
What is it doing?
It's still. No.
It's sitting still, so velocity is what? 0. Oh. And it has, it's at rest. Let's put here, that was at rest. This was what?
Forward.
Moves to the right. Okay, what is this one doing? Moves left. This moves left. What's the velocity there? Oh wait, hold on, moves left. I should say left because you're going to think that says up. Moves left, and the velocity's what? Negative. You still with me? Okay, what about here? Velocity's what? Negative, moves what? Okay, what about here? Velocity's what? Come on, freaking out on me, boy. Velocity's positive, so what does it do? Moves right. What about here?
Stay still.
Constant, velocity 0. What about here?
Velocity's positive.
Velocity's positive, so it moves what? Do you see that the slopes are related to the derivative, which is the velocity? Therefore, velocity tells you if this object, the sign of the velocity, whether it's positive or negative, is going to tell you really what the object is doing. It's going to tell you when it's moving right, or moving left. Because when you look at the position graph, what can you summarize from position? That when the slopes are what?
Positive.
The velocity is positive, which means it moves right. When the slopes are what? It means it's moving left, which means the velocity is what? That's why the sign analysis for velocity is so important, because the velocity is going to tell you what the original particle is doing, what it's doing, when it's moving right, when it's moving left. Now, when you graph velocity, it's actually going to be a plot of those slopes. Where the slopes were positive is where the velocity is going to end up above the x-axis. Where the slopes are negative is where the velocity is going to end up below the x-axis. Where the velocity is constant, or where it's at rest, is where the velocity is going to equal 0. It's going to cross the x-axis. So that's good for position. Did everybody get that? Relationship between position and velocity. Now I want to relate one more thing. You ready? Okay, let's go to velocity graph. Can I erase this? Okay. Let's do a velocity graph. Should have just done a velocity graph right off that, but I'm going to do a new one. Let's do a different one. Okay, just going to erase this now. You got that. So velocity, v of t. And let's do this. Let's go same thing, 0 to 9 or something like that. And let's go by 5s again. This will be 5, 10, 15. But this is not position anymore, so velocity is not measured in meters. It's going to be measured in meters per seconds, let's say. So we'll have time. That'll be in seconds again. Now this is going to be a plot of velocity. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's good enough. All right, here we go. Let's start at a velocity of 10. Let's go to a velocity of 0. Let's hang out here down at negative 10 for a while. Come back, keep the x-axis, stay there for a moment. Go up to 50. Let's go up to 5. Let's go up to 10. Let's just stay there. There we go. There's the velocity curve. I'm actually going to make it go a little further. Let's have it go back down to 0. All right. Now, what does the velocity tell you? See if you paid attention just now. You got to be on it. It tells us the slopes of the original. Remember, this is calculus, okay? The derivative of position is velocity. So this graph, velocity, is specifically telling me what the slopes of position were. So wherever the velocity is positive, for example, at 0 seconds, you're at a velocity of 10. So that means the slope on the original graph was what at 0? Was actually 10. If you go to 5, go over here to 1 second, what's the velocity? 0. That tells me on the position graph you had a horizontal tangent. Okay? All right, because this is plotting the slopes, right? Okay? This right here, at this point, at 2 seconds, you're at a velocity of negative 10. So this is negative 5, this is negative 10. So I'm at negative 10, tells me the slope on that graph at 2 seconds is negative 10. That would be the slope of the tangent line. So this is the slope of the tangent lines for the original graph. It's a plot of those slopes. Now, this is what I want you to make the connection of. Yes, I know it tells me slopes for position, but more importantly, it's telling me which direction it's going. Because we said in the original position, when the slopes are positive, it's moving what? So when the velocity is positive here, not where its slopes are positive, but when the velocity is actually positive, it's moving to the right. When the velocity is actually negative, it's moving left. So when I look at this, I see, hey, from 0 seconds to 1 second, the velocities are what?
Positive.
So which direction was it moving? But it was coming to a stop, and then it was going to do what? Change direction, and now everything below, which direction is the particle moving? Left. So then it reaches a certain speed, kind of hits cruise control for a while, slows back down, and then what does it do? Kind of pauses and say, I forgot to turn off the oven. I need to turn around and go back. Turn around, go back, reach a constant speed, and then eventually slow down. And then we don't know what happens after that. So from this velocity graph, I can tell the original particle, the object, is moving right, left, right, because it went above, below, above. Okay? That's interesting. All right? But what I want to do is make the connection now, and I want to connect this to acceleration. We saw how position related to velocity. I want to see how velocity relates to acceleration. So for all you people who haven't had physics and just had 9th grade physical science, this is going to be new for you. For those of you who had physics, you probably made this connection in physics class. And that is, just because the acceleration is negative does not mean the particle or the object is necessarily slowing down. And the reason for that is because we introduced displacement. Displacement was not the same thing as distance, was it? Because displacement represented a distance from the final position to the initial position, but that distance could be negative, right? So now we brought this negative into the problem. And since distance can be positive or negative, velocity therefore could be what? Positive or negative, and therefore acceleration is not always going to be positive, because we're not going to assume, acceleration will be positive or negative. But because velocity can be positive or negative, it's going to affect how we interpret acceleration. Because acceleration in 9th grade was positive or negative. When acceleration was positive in 9th grade, it sped up, and when it was negative, it slowed down. But now, because velocity can be going, because it's bidirectional, it can be moving forward or it can be moving back, it's going to affect how we interpret acceleration. I want to show you how to make that connection right here on this graph. So please take notes on this. This is the big thing I'm going over. I'm going over this and total distance. All right. I think it's really clear when you look at a graph what it's doing. And I think you're going to think it's very clear. I'll use a different color here. Everybody look from 0 to 1. Tell me, what is the velocity right now from 0 seconds to 1 second? The velocity is what? It's positive. How do you know that? Above the x-axis. Can you tell me what the acceleration is, though? How do you know it's negative? Because it's the slopes. From 0 to 1, the slopes are negative. And since velocity, or the derivative of velocity, is acceleration, if you want to look at acceleration off of the velocity graph, you have to look at slopes. So if you look at slopes, you can actually tell what the acceleration is doing. In fact, I can tell from 0 to 2, the acceleration is what? From 2 to 4, what's the acceleration? 0. From 4 to 5, what's the acceleration? From 5 to 6, what's the acceleration? From 6 to 8, what's the acceleration? From 8 to 9, what's the acceleration? And from 9 to 10, what's the acceleration? So when you look at slopes of velocity, you're actually looking at acceleration. Now when you look at velocity, you're just looking at where it's above and below, and you're going to have to start keeping that stuff straight. So let's just look at this tiny part. Here velocity's positive, acceleration's negative. What about here? What's velocity here? Velocity's negative and acceleration's what? Negative, okay, good. What about here? Velocity's not 0.
Velocity is negative.
Velocity is negative. Acceleration's what? 0. We'll talk about all the implications of this in a second. What's this?
Or negative.
Velocity's
Negative.
lab output.
Positive.
How can I fix that?
No, just hit undo.
There is no undo on this. Velocity's negative, acceleration's what? Positive. What about here? Velocity 0 and acceleration's what? 0. What about here? Both positive? What about here?
Positive and 0.
Velocity's positive. Acceleration's what?
0.
Good. What about here?
Both negative. Or
Positive.
velocity's positive.
Velocity's positive. What acceleration?
Negative.
Okay, got it all? All right, I think it's very clear, and I think you'll make the connection here, and we're going to see a relationship. Okay, I want to ask you if it's speeding up or slowing down. I want to ask you, is the object speeding up or slowing down? And I think you'll be able to see it easy from the graph. It's usually very clear when you look at a graph. Because when I look at this from 0 to 1, I'm at a velocity of 10, and it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What's happening? Is the object speeding up or slowing down? Slowing down. What happens here after 1? Speeds up. What happens here?
Doesn't change.
Doesn't change. It's at a constant velocity. What happens here? Slows down. What happens here? It's at rest, and it's at constant velocity is 0. What's happening here? Speeding up. What's happening here? Constant velocity. What happens here? Slows down. Can anybody look at the graph and just tell me an easy way to look at that?
Sides are opposites.
Don't get to that yet. Not yet. Just look at the graph. How can you tell me looking at the graph if you can tell it's speeding up or slowing down?
Oh. Which way the line's
David, say it loud.
If it's approaching the x-axis,
If it's going towards the x-axis, what is it doing? Slowing down, because your velocity's your velocity's decreasing. Okay. If it's going away from the x-axis, what is it doing? Speeding up. Because the slope, the derivative of velocity is acceleration. Because you're thinking 9th grade. Okay, you're thinking strictly when the acceleration's positive, it's speeding up. Acceleration's negative, slowing down. I'm here to tell you acceleration can be negative and it still speeds up. I'm here to tell you acceleration can be positive and it slows down. Okay, so this is clearly slowing down. This is clearly speeding up, but that don't make sense because the signs acceleration's negative here.
It's just because it's relative.
That kinda
to
makes
the
sense.
direction it's moving.
Because direction changes everything. So David's statement is exactly correct. When it moves towards the x-axis on the velocity graph, you're doing what? Slowing down. When you move away from the x-axis, you're doing what? Speeding up. But how can I summarize the calculus? Let's say I don't have the graph. What if all I have is equations? What if all I can do is get a position equation, a velocity equation, and an acceleration equation? Well, I can analyze the sign of it because I taught you how to do that yesterday, and we're going to do that again today. And then what you're going to do is you're going to look, can you just look at acceleration to tell whether or not it's speeding up, slowing down? No. Because your acceleration was negative, but it was doing what? Speeding up.
Yeah, but it's moving away from the x-axis.
But what if you don't have the graph? How are you going to tell? What if all you have was velocity and acceleration equations? So can anybody look at this now, Jacob, and tell me how you can summarize when it's speeding up and slowing down?
Sign.
What?
Sign.
Say it.
The sign.
Sign. What about the signs?
They're both the same. They're speeding up, so they're speeding up.
All right, that's the key. When the signs are different, what was it doing?
Slowing down.
When the signs were the same, what is it doing? Speeding
Yeah,
up.
but it's different there, and acceleration's not moving, so it's staying the same. So
Well,
it's-
when acceleration's zero, it doesn't matter. That's constant velocity. Okay, so acceleration's zero, then automatically you know it's constant velocity. But if the acceleration's positive or negative, now you got to look at velocity and see if it's positive or negative. Because what you see here, hey, velocity's positive here, acceleration's negative, slowing down. Here, velocity's negative, acceleration's negative, now it's speeding up. What do you think?
It was inconclusive.
Really?
Yeah, I have to have another one to get my mind
Also,
around.
it's good. If velocity is negative,
He's implying he wants one more.
I know, go ahead.
I'm gonna learn something first.
If velocity's negative and acceleration's positive, what are you doing?
You're slowing down.
Slowing down. If velocity's positive and acceleration's positive, you're spinning up. So what can we summarize as the relationship between velocity and acceleration?
If they're opposite signs, it's slowing down. If they're same signs, it's speeding up.
So let's write that down. Okay? If velocity and acceleration, here we go.
Yeah, I was wondering, when did you guys morph into physics?
This is calc, you have to.
Don't have to.
You have to, it's on the AP exam.
On the AP Calc or?
Every year, one free response. All okay, speeds up. Speeds up when?
Positive or same.
When signs are same. When BFT and AFT have same sign. You writing this down?
Even if they're negative?
Yep. Because if they're both negative, velocity's negative, that just means you're going from 0 miles per hour to negative 10 miles per hour. It just means you're going left. Acceleration's negative, you're moving away from the x-axis, you're speeding up. So you're like the 9th grade physical science student that assumes, like they teach that distance is always positive, but mathematics distance can be negative because we want to know direction. If it's positive, you're moving right, negative, you're moving left. Which on the flip side of the x-axis, everything's backwards.
Okay.
All right, so slows down when what? Slows down? You keep licking your finger?
Yes.
Slows down when VFT and AFT are what? When they're what? When they have different signs. And on the AP exam, just so you know, since we're talking about it, on the AP exam on the first month, you have to justify why this is true. Canyon just can't say from 0 to 2 seconds it slows down. Well, great, Canyon, thank you for the answer. You could have cheated. Can you tell me why? He's going to have to say it slows down from 0 to 2 seconds because velocity was positive and acceleration was negative, or velocity was negative and acceleration was positive, or he could say they just have different signs. But he will have to justify why. If he says speeding up, he'll have to say that they both had what? The answer is not acceptable without the justification. You have to justify your answer. Okay? Questions on that? Let's try this problem then. Here we go. So a particle moves along the line. How many of you tried A through D on your own? Okay, can I go through the answers here? We're going to speak through these two, and then once we get these two done, we can eat. Okay, so if you're with me, I'm with you. Okay? All right. Are you like charging your iPad from your backpack?
Yeah.
Only you. Okay.
I
You're
thought
welcome.
it was
Is it
low.
good though? Do you like the chili cheese?
Yes, wonderful.
It's even better this time. So we put like extra seasoning in it. A particle moves along a line so that its position at any time t greater than or equal to 0. Pay attention to that. Everybody start writing, because this is it. You've got the problem for the test tomorrow right in front of you. You're crazy if you don't take advantage of this. Okay, I'm doing 2 problems like the problem on the test tomorrow. Okay, this is going to be the free response. I mean, I'll change the equations a little bit.
Oh.
Okay,
It's
just not gonna
the
give you,
same.
no, not gonna give the same. All right, particle moves along line at any position time t greater than or equal to 0 is given by the function s of t. What have they given you?
Position.
Position. Where s is measured in feet and t is measured in seconds. All right. Part A, find the displacement of the particle. How do we calculate displacement?
Original or final minus initial.
And they want from 0 to 5. So we're going to have to find what 2 things to calculate displacement.
That's a,
You're going to have to calculate s of 0 and s of 5. Which one's the end position?
That's the 5.
So we're going to have to go s of 5 minus s of 0. Now, if I don't do it in that order, it's not going to give me the direction of the displacement correctly. So you want to go end minus start. Now in a minute we're actually going to change you, and I'm going to say it's not going to matter. It doesn't matter in 2 situations. When we do total distance and when we do average velocity. I'll tell you why. But when you're actually calculating displacement, it matters. You got to go end minus start. Is everybody clear on that?
Yes.
Does order matter when you're calculating displacement? Yes. All right, so what is S of 5 off the top of your head? Who did it last night? Come on, I don't want to sit here and calculate. It was 0? I think you're right. 0, and then what's S of 0? 100. How did you get those? Just so we know, plug it into the original equation, because this calculates position at any time. And what we end up with is a negative 100, which means, and that's feet, what does that mean? It means you were displaced 100 units to the left. Okay, part B. Here we go. Average velocity. How do we calculate average velocity? We do displacement divided by change in time. Now, here's where displacement, the order doesn't matter. And we'll prove to you the order doesn't matter. Because this formula really is S of t plus delta t minus S of t over delta t. And the reason the order doesn't matter is because this really is a formula, watch, of y2 minus y1 over x2 minus x1. When you did a ratio, could you flip-flop the order? As long as you flipped it where? On top and bottom. So here, you don't have to do displacement as end minus start. Only when you do it by itself does it matter. Okay? But we'll, to stay consistent, we'll keep going it that way. We'll go S of 5 minus S of 0. And I think you can see it here. Most of you are like, oh yeah, that's just y2 minus y1 over x2 minus x1. We could flip-flop it and go x y1 minus y2 over x1 minus x2, and we'd get the same answer. Okay? What we're going to end up with is negative 100 over 5, which is what? Negative 25.
no, 20.
Negative 20, what was I thinking? Negative 20 what? Feet per second. That's our average velocity. Okay? Now we're going to go on to instantaneous velocity, because who cares about average velocity when you can calculate instantaneous velocity? Cop's not going to care. Well, I averaged the speed of 60 miles per hour. Yeah, but you were going 80 just a minute ago. Okay? He ain't going to go with your average. He's going to go with your speedometer
What
reading.
if I should have?
It doesn't matter if you went 80 for 1 second. Your average only ended up being 30 miles per hour. He ain't going to say, well, you averaged a grandma, but you spent like Jeff Gordon.
But when you go
Okay.
to sign an NBA contract, you're going to care whether you're scoring average of 10 points a game, and now that you scored 100 points last game.
Average makes sense there, but not when you're driving a car. Okay? There's sometimes when the average makes sense. Average velocity is not really important. It is sometimes. All right, instantaneous.
You take the derivative.
We take the derivative. So what is the derivative of position? Look up here. What's the derivative of position?
32, 60,
Velocity, which happens to be what?
negative 32.
Negative 32t plus what?
60.
60? Okay? Those all low now, I think. Maybe, yeah. Are they all low now? What's the dip getting? Syrupy?
A little bit. I need to stir it in.
Just don't lick it.
Huh?
I'll lick it. Alright, anyway, so
I was
this,
putting it on the side of the plate in this.
so now we're going to calculate S prime of what?
5.
5. We just plug in 5. Don't make this hard tomorrow. If you miss A through D tomorrow, you need to go home and cry.
So we have a negative 100.
Okay? I'm not kidding. I am not joking. Well, maybe D. But A through C, please cry. Okay? But you should. 'Cause you should be able to get that. That's not hard for you guys. Now, if you make a math error, you might want to scream. Okay? But you should know this just because you know it. And I get it. Once you get to D and on, now give yourself a break and say, yeah, it's a little bit harder now. Okay? But these should be giving points. Negative 32 times 5 plus 60, what do you get?
Negative 1.
Wow, negative 100. Really?
Because this isn't at 160.
Wow, crazy. Okay. Negative 100 feet per second is the instant. Is he looking at again?
No.
I know the point that he's gonna work for that.
So he's slowly but surely diminishing.
Mason, you're being unsanitary.
I'm not.
I'm going to let Thomas go and do it.
You can do it this
We
time.
got a ladle.
Yeah, but
Okay. Get it in there and get it out. I don't care though. Any questions so far on A through C? How many think, yes, I'm guaranteeing I'm getting those 3 right tomorrow, barring math error. Okay, can we guarantee those 3?
Yeah.
Now, here on, a little harder. Okay? Here's what we do. Next step, describe the motion of the particle. Here's what you got to do. To describe the motion, you're going to have to analyze the sign because you don't have the graph. Now, this one's easy enough to graph, and I'm going to make tomorrow's not easy enough to graph. Okay?
you just plug in like every from like 1 to 5.
So we've got V of t is equal to negative 32 plus 60. How do we analyze the sign of a function?
You gotta find the correct answer.
Figure out where it crosses what?
X-axis.
Why? Because the sign can change. And I went through this yesterday, so look at me and listen. The sign can change from below to above or above to below in what situations? When it crosses the x-axis or discontinuity, jump or asymptote. Do we have any jump or asymptotes in that derivative?
No.
No, so the only thing we're worrying about is where it equals what?
And what kind of particle motion question would have asymptotes anyway because it's measuring distance?
It will, don't worry.
And plus you can only have one, like a cross x-axis.
I'll give you a trig one, it will, don't worry. Particle motion, yeah, I guess it won't happen that often, but we're going to run into ones that will, just trust me. Okay, so we're going to get, if I solve this, I think I get t equals 15/8.
Yeah.
Now, pay attention to this. This is kind of important. Now, when we did our sign analysis yesterday, we're going to analyze the sign of VT. Now, you don't have to write sign analysis for VT, but I'm going to, just so we know what we're doing for notes purposes. Sign analysis for V of t. So we're analyzing the sign. So what we wanted to do first is we wanted to split up the x-axis into intervals at where potentially it would change from above to below. What's the only point it potentially can change from above to below? At 15/8. Okay? So we're going to have from negative infinity up to 15/8, and then we're going to have from 15/8 to infinity. But they said we only have to care about time greater than or equal to 0. So do we really have to go from negative infinity?
No, it's
So where can we start our interval?
0.
So we're going to go from 0 to 15/8,
So 50 is 250.
and then 15/8 to infinity.
So you're gonna plug in 0 and find out what's positive.
You good with that? Now, all I'm going to do is I'm going to pick a test value between 0 and 15/8. What's the number between 0 and 15/8?
25.
Don't use the endpoints. Don't ever use the endpoints. 1. Let me just train you not to use the endpoints, because usually those endpoints equal 0. Okay, so do 1. If I plug 1 in, 1 is what?
Negative
32. Negative 32 plus 60?
3.
Positive. So what does it mean if the velocity is positive? It's above the x-axis, which means what? The slopes for the original graph are going uphill, which means the graph is moving which direction?
Positive.
Away from the x-axis.
But that don't matter on position.
Right.
Positive slopes on the original graph means it's moving right. It's right.
That's supposed to be here.
Moving away and from the x-axis has to do with speeding up, so you know. All right, 15/8 to infinity, that's about 1.875, so let's test 3 or 4 or 5. Just test something big, just be like, okay, 10. All right, negative 32 times, really big negative plus 60 is going to be negative. So what does it do?
Left.
Moves left.
But would you not have to do that since it's only a t to the first?
Huh?
Would you not have to do that since it's t to the first? Like plug the value?
I haven't talked to them about that. You watched the video, so it does alternate, but we'll just test them all until I teach you the shortcut officially. But if you already know it, go for it. All right. Yeah, t to the first. It would have to alternate signs. All right, so we got positive, negative. So when it says describe the motion of the particle when it's moving left, right, or at rest, here's what you would do. You would say the particle moves to the right from what?
0 to
0 to 15/8, which tells me the original function had to have uphill slopes. The particle moves to the left from what?
It's
15/8 to infinity, and that would mean the original function had negative slopes. When is the particle at rest? 15/8. Now go, this is really easy to answer. Like E, if you get D right and if you miss E, cry more. Because if you did D right and you can't get E right, cry more. A lot more. Because this is just natural. It just flows right. Yeah, it moves right, it moves left. Obviously it did what?
Change direction.
Or we just don't have common sense then. Okay, it changed directions. How do you know it changed direction? Because the sign of velocity what? Changed. If you already interpreted all this junk, I know you're going to get the change in direction right. You're going to be like, yeah, the change in direction went from moving right to moving left. It's like to the 50th power. Okay? Now, speeding up and slowing down, I think about half of both the classes combined are going to get. Because they're not going to pay attention well enough. But we've already wrote a summary of it. What did we say we have to do to figure out speeding up and slowing down? You're going to have to compare velocity and what? Acceleration. And when we said velocity and acceleration have the same sign, it's what? Speeding up. When they have different signs, slowing down. So now we're going to have to do a sign analysis not just for velocity, we're also going to have to do a sign analysis for acceleration. So what we need to do is find the second derivative, which is a of t, which is the derivative of velocity, which is the second derivative of position. You don't have to write all those. And that is going to be negative 32. Now this one's awesome because negative 32, it's a constant. Will it ever cross the x-axis then? Does it have discontinuity?
No.
So there's nowhere it's undefined or 0, right? So what is it always going to be?
Negative 30.
So what you would say is your sign analysis for a of t would be 0 to infinity. There's nothing to break up the interval. And you'd say it's always either positive or negative. What is it in this situation? Always negative. Now here's what some people are going to do. They're going to say, well, it's always slowing down. And I'm going to say, no, you're not. It does not always slow down. What you got to look at is you got to compare. You got to say, just like we did on that graph a minute ago, we got to think about it. Velocity's positive, but acceleration's negative. So from 0 to 15/8, velocity was positive. Where is 0 to 15/8 going to fit here? Well, the whole thing's negative. It doesn't matter, right? So if velocity is positive and acceleration is negative, what's happening from 0 to 15/8?
Slowing down.
It slows down. Now, in the AP exam, you would have to say because the signs are what? Slows down because signs are different, or because VFT is positive and AFT is negative. So it slows down from 0 to 15/8. What about from 15/8 to infinity? Speeds up. Why? Because it's negative, negative. Velocity's negative, acceleration's negative. When the signs are the same, speeds up. You got that? Make sense? One last thing to show you and I'm done. Now, before I do that, most of you be like, gosh, I could have just graphed velocity and I could have just looked at what David said and I could have just done my sign analysis from the graph and I could have just said, 60, negative 32, it crosses at 15/8, which is approximately 1.875. Watch me. Are you watching? I'm going to graph velocity. You ready? Has a negative slope and it crosses way up here at 60. Velocity's positive, acceleration's negative, moving towards the x-axis, doing what? Velocity's negative, acceleration's negative, moving away from the x-axis, doing what? That makes sense. Totally makes sense. Need you to make the connection for both. Now, some of you are like, well, I'll just do it this way. No, you won't. Because the graph will get way too hard to graph. It's not always going to be a linear derivative. This derivative might be t to the third power, and how many of you are going to want to take the time to graph something like that without a graphing calculator? Not me, because it might even require synthetic division to be able to graph it. And I know how you feel about synthetic division. Okay? There's one more question I want to answer here, and that's total distance. Total distance. Now, we already have a sign analysis for this. I want you to think about it. This is not even a question, but it's going to be a question tomorrow. It's the last thing we need to cover. Let's say I added and I said G. Find total distance from or in first 5 seconds, from 0 to 5. You can do it like this, 0 to 5. From 0 to 5. Now here's what you need to take into consideration. Let's say I'm this particle, and I'm starting here at, does anybody know my position? What was my position at 0?
Negative.
Negative 100? What was my position at 5? 0. So I'm way over here at negative 100. And I must be running. Okay? Because in 5 seconds, I'm going to make it all the way to what? 0. But does that what really happened? That is not what happened. I did not just move right. What did I do? I moved right and then I moved what? Left. So what you have to, and here's the way I'm going to explain this. If I was calculating that if I started here and you started counting my distance, just count my distance, not my displacement, my distance. My total distance is 6, but what's my displacement? Because what I did is I ran over top of displacements. In one way, it's a positive displacement. The other way, it's a negative displacement. What just happened? Cancel. The total distance, that's not what we're after. We're after how far did we actually travel. So what are you going to have to take into consideration? What's the most important part when you're taking into account total distance? Not just counting how far you went, but what else?
How many times you go to the same spot?
Which really is going to have something to do with what?
How fast?
Critical point?
Not how fast is your roll. Well, it does affect it, but
Corners.
what? How many times you change direction? The most important thing you're trying to keep account of when you're trying to figure out total distance is you got to take into consideration every time you do what? Change direction, because that means those displacements really did what to each other? If I was just going one way, would displacement and distance be the same? But it's when I change direction that displacement and distance are not the same. So if you're going to calculate total distance, listen, all you have to do, you have to calculate all the displacements that would occur with what taking into consideration? With taking what into consideration? Change of direction. So you're going to have to say, all right, from 0 to 5, does it ever change direction? So what you're going to have to do is calculate the displacement from here to here, and then calculate displacement from here to here. But here's the problem. One of these displacements is going to be what? Negative. So how are you going to make it distance? Absolute value. That's what you did in geometry. I don't know if you remember that, but anytime you wanted to find distance, you took the what of it. So what we're going to do to find total distance, here's the formula. Ready? Total D. TD. To find the TD from 0 to 5, you're going to calculate the distance by calculating displacements, taking into consideration every change of direction. What did I just say?
Every.
So you're going to calculate displacement from the start to your first change in direction, and then that change in direction to the next change in direction, and that change in direction to the next change in direction until you get to where you want to stop.
Well, what if it's infinity?
Well, you won't, because you'll have to have an interval. You can't find total distance from 0 to infinity. You never stop. Okay, so it'll be an interval. It'll be a closed interval from 0 to 5 or 0 to 4 or 0 to 3 or 0 to 10 or something. It will be closed off. You'll have a stopping point. So what I'm going to do is I'm going to go, watch, I'm going to calculate, ready, check this, and I'm going to take the absolute value of those displacements to make sure they're all what? So I'm going to go start. I'm going to go in order. S of 0 minus S of what? What's the change in direction here? 15/8. Now, some of you already have a problem with this, and I said I was going to show you 2 times that displacement, the order didn't matter. Average velocity, it didn't matter, and total distance, it doesn't matter. Why does the order not matter now?
It's going to be positive.
Because you're going to take the absolute value anyways. Plus, what's the next one? What would the next displacement you'd have to calculate? S of 15/8 minus what?
Or S of 5.
S of 5.
Where are you getting 5?
Because I said, find the total distance from 0 to 5. That's easy, isn't it? You just, total distance 0 to 5, just make sure if there's any place you change direction, you measure the displacement to those change in directions. And wherever you leave off, somebody said, well, S of 0 to S of 15/8, this is what they tried to do. They tried to go, well, where do I start from? You start where you left off. So just go in order and start where you left off. They were like, well, do I go back to S of 0? No. Would you do that? Okay? So S of 0 was what?
-100.
Now, I don't know what S of 15/8 is. Can somebody help me?
You plug that into your original equation.
If you want position, this is S to plug into the original. Who's got it? Just use your calculator to do it. All right, negative 68.75. What are you saying?
Yep.
Seems wrong.
How do you get a negative out of
I
that?
got 156.2.
Yeah, that it should be
Yeah.
because it had to go past 0 because we ended at 0.
Yeah.
Because it went right.
Oh,
Because the particle was
Yeah.
way over here at negative 100. It went to the right and came back to the left and ended somehow at 0.
yeah.
Okay? So you're calculating all this displacement and adding this displacement. And if we don't make them both positive, these two segments here from here to here would do what to each other? They cancel each other out. That's why you gotta have the absolute value. Does that make sense? So what are you saying it is, Candy?
156.25.
So minus 156.25 plus absolute value. Is it negative or positive? Well, it was positive, obviously. No, 'cause I'm subtracting. Minus, what was S of 5?
0.
0. All right, here we go. That looks right. Negative 100 minus your 156.25. So this is going to be a negative, but absolute value of it becomes what? So 256.25. Watch this. What this got is it got that, and it got that. Now we come back left. That's going to get the last part.
So 412.5.
That'd be your total distance. Any questions? Now, hold on. I have the second problem. Let me just go over the test, and I'll let you guys get started before they get here. Okay. The second problem is right there. There is a video on that problem already done. Okay. There's a video already done on that problem that you can do that problem and try it. Homework tonight. Okay. Is the particle motion problems. Particle motion problems right here. There's 4 of them. I'll have the answer key up by 8 o'clock tonight. I only want you to do the first 4. That's it. So what are you studying? All your what? Now, the derivative rules were under Tuesday, February. Write this down. Tuesday, February 10th is where the derivative rule sheet was. Tuesday, February 10th. Everybody say it. Tuesday what?
February 10th.
All right. Study all your derivative rules. There's going to be 3 for response. 3 for response. Yeah, I'm not going to let him in yet. 3 for response.
Even on the
And then
drawings.
guys, do these 4 particle motion problems tonight. I'll put the answer key up by tonight so you can see if you get them right. Okay?
Okay.
Now, you can grab a hot dog, but I do need somebody to help me go grab the drinks. If nobody's interested in waiting in line that long, would like to help me go get the drinks because they're super nice.
Can't even tell our whole class.
Who's get in line? You should really let the ladies go first because that'd be the polite thing to do.
You know we could, but then again,
Hey, only take 2 hot dogs until everybody's had one.
No, Matt, no.
Nobody wants to come and help me grab pop by myself. And do not go obsessive on chili until everybody has some. Are we clear? That's $45. Everybody should get some.
Billy, we're all seniors. You can't just buy this.
No, I'm going to get
Hey, scoot back. Everybody scoot back. You're lying. You're crunching them. And but there's plenty of chips. Please eat chips.
This is just having your fun. Moist. You haven't gotten the hot yet, right?
I'm going to go get it. You gonna help me? There's a line. I think I'll help you get pop.
Hi, Jackie. How are you? Kyle. Morse is talking, like, our class got talking about Morse. You got paddle when you're in school.
After Taco Bell, anything's possible.
How you had to bend over and you could paddle.
No,
You would, like,
don't eat there.
It's just like,
Have fun working out with that. You got feet? I got feet. That'll be good.
We're on a plus sign. No more anatomy. I'm so happy.
plus sign, you passed your test.
What?
You passed your test.
I don't know about that. I'm pretty positive I passed it, but I
Was
don't
your
know.
grading affected?
Huh?
Getting affected by the gas.
Hopefully.
Did you
Hopefully
take-
it'll increase.
Are you in college anatomy?
No.
No.
Oh, I thought you were. For some. What'd you get on the modal portion? You got 1 wrong. I hate you.
Damn it.
Dang it! I got 5 wrong.
I don't know how much I got wrong. I know my score if it's not good.
Colin, did you take the modal portion? I didn't hear it. I thought I was. Oh, I thought you were saying you got perfect.
I thought I was answering them right, and then I get my results back, and I'm like,
Just don't spill the pot, please.
I'm pretty good now at modal tests and like if I think I'm finally sure about flagging it and then I'll be like,
I usually
yeah,
do
know
flag
this.
it. I usually do flag it, and I double check mine too, which doesn't mean
I just like go through it and then if I'm like kind of questioning it, I flag it and then I'll get all of it. It's not so bad.
No, it's cold outside, so you should wear pants.
Good call. You can call one wrong.
No, right?
Because your hands are
Don't do the extra credit.
You're too smart.
Don't do it. Really? Not?
What's the extra credit?
It's on the
like
board.
answer those questions on
Yeah,
the board,
extra
but I
Like
didn't
one,
get them because
one
I
will make dissecting the catheter, and then like overall, what'll like where should we spend more time in the class? And I wrote lectures, very large lectures. Give us lectures.
I would do the extra credit because I was
I do.
Oh,
like
guys.
that. I mean,
Guys, should we
lecture
listen to
days,
this while we
just
eat?
lecture at the time. And then, like,
Anyone?
I need
Yeah,
to
let's
tell
do
me,
it.
No.
Alex Swanson.
Oh, Joe, these are so good.
Yeah, and I also said like
I'd rather just not
discussing what we're gonna do the lab on before we actually do the lab.
Especially when
For the
the
cast.
camera's gone. We can make a video.
Carl.
It's gone through the entire day. You left me.
Yeah.
I'll take one of this.
Depends on how far Nathan and everyone else is willing to take me.
Start off with
You want me on today? Morris. Morris, we need some music.
chili cheese broth.
Why?
Because it's available. Right here.
Yes, one.
Woo! You need one. One house.
Yeah.
That's like 2 seasons straight. You haven't used
Don't spill that.
went straight to football and basketball and you don't.
I think I have when you're going.
We might have had a week off. We had, I think
AJ, you're such a smart aleck.
we wouldn't have expected that.
Oh, wow. Make sure you take it.
Of course you are. You're gonna be
Make sure I say me one.
No, me.
Oh my God.
Patrick, grab me a glass.
What?
Grab me a glass. He plays hard.
What kind?
You don't think I have my high school that time?
Yeah, I'm alright.
Well, I almost feel bad for Joe and Ryan.
I know. No. They told
I
us
sent you a Snapchat.
I'm skipping next Thursday, Friday for the Boy Scouts.
I can't do it.
Are ya?
Yours is right on there.
Oh, I need
I know,
dessert.
but I like barbecue ball.
Ellie, that's really good.
Who you
I
want
don't know where
to
that's sit.
Now, what are you
Oh, you
doing?
gotta get in a hotel.
I need to text your wife.
That's you walking?
Going to Paris sometime today. You're not skipping, just skipping. Is that a CNA?
I'm definitely doing that.
What?
Oh.
Y'all better kill these chips.
Sure, AJ.
Alright, so we don't wanna get one because there goes
No.
fast.
Natalie?
That's nice. What are you doing? Just pick it up.
Thanks, Mr. Morris.
You're welcome.
Yeah.
Appreciate
Did you
it.
see that?
Yes. You like that?
I knew it was you, because your name was right under it.
Morris, thank you, Morris. Morris, how much would
Thank
it,
you.
how much would it cost?
Thank you.
You gotta make this.
I can't reveal the secret.
That's my graduation year.
Was that one?
That would be fun.
Yeah.
I didn't know.
Just wait until graduation.
At our graduation ceremony, that'll be your speech. She'll just walk up there, 4 cups.
Prison dip.
Here's,
Yeah, they need to hit
here's,
the same
here's the secret.
It's kind of like
I'll just explain for 10 minutes how to make it.
Yeah.
it's weird. It's like
Don't like give any like. Don't let anybody else know what you're talking about. I'll just be like, for those of you who know,
You had to make
this is how it goes.
Yeah.
Oh,
I don't know. Look at
I feel good.
Wow.
One volunteer.
If I do speak at graduation, I have to say Bill Hole in my speech.
Why?
Just go.
Just because it's funny.
I still want to know how I got that nickname.
No, I want to know.
Nickname.
Bill Hole.
I think I even know.
I do.
Billy.
Hey, should we take a picture and Snapchat it? Who's got Snap? Joe. Snap.
You're
Alright,
a did.
good. There's plenty of dogs. I think we had enough.
Morris, do you have forks?
Exactly.
You have a fork? No, not either.
Morris, we should do this after the AP test.
We are.
Oh, sweet.
Do we get to celebrate 5 years?
Yeah.
Oh,
She
it's
was
it.
complaining about how they failed it so hard.
She was great. I was watching her as she was grading. She was getting so frustrated.
It'll have to be
She
a-
either
that's
got an
Are we gonna get credit for?
a miserable nap.
Where are the tortillas? Yeah,
I don't know.
Canyon, give the tortilla chips. You can't just
Yeah,
grab a
where are
bag
they?
and keep it to yourself.
What in the world?
Wasn't this,
You are the biggest food whore.
Yeah.
I just picked them up and set them over here.
You know the biggest food hoard in the school is I have a mixed hour.
Cool.
It's insane.
Or Christian Wise, you read him?
Oh my god. He's eating more sweet like Swiss rolls than
Swiss themselves.
what?
What, Pat?
Said they ate more Swiss rolls than the Swiss themselves.
Oh, no.
Here's a funny joke for you.
It is so good.
It's like pudding.
Over cookie.
It's like
You're crazy.
The pudding.
I can't eat
That means,
I get sick a lot.
that means your wife, she'll
No,
have some pudding
I'm
everywhere.
I'm on two.
Hot dogs?
Yeah, I have
Why'd you
some.
buy ice cream? Because I don't like it. I know you'll eat it.
I'm glad.
You're gonna give yourself
I'm glad I went and got an extra thing of bun. Did you bring me that receipt for my credit card back?
Yeah, I put it right on your desk.
They fill up their gas.
How much was it?
It was 16 something.
Oh, stop.
Buns, hot dogs. What else am I supposed to do?
When's the last time? When was the last time we did this?
I gotta take a picture.
Like,
Because my friend made the chili cheese. Stuff on it. I just helped him.
Oh, give me a napkin,
so
please.
how do you manage to do this?
I
During
can
January,
I mean, I can send you my
what are some
house,
ties?
so, like, I don't
Oh,
have to
it's-
go there.
Over there.
Oh, no. I know. And no trail slider.
Say goodbye to it.
I forgot. It's all my fault. I'm a terrible parent.
You forgot about lunch?
I did.
No.
Yeah.
It's like,
Like, I'm not sure.
go support the girls tonight.
Yes, please. Nate's already gonna be there, so you know it's gonna be good.
You got me one?
You ready for Monday?
Is Kate gonna be coaching us or no? Could be hopping around.
No, I hobble for sure.
Natalie, I love you.
Questions up?
What?
I heard that. I heard that.
He only got one wrong.
Yeah, I know. I heard that too.
Anatomy.
Should I first test for everything?
Yeah, one wrong. I heard that.
Sucks. Way to go, T. You screwed it up for everybody. UCT. Well,
I know ideas all the time.
way to go, T.
Yeah, that's what I'm gonna do.
Why are you You're the messiest person I know. I can't do it.
Anatomy only small guys.
Yeah.
Yeah, college anatomy next year is gonna be free. I say that. Oh, I want 'em.
Is it a free charge?
College will be next year.
Come on. Throw free enough.
No, she's a
Show me a hit. Pat, 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 pat.
No.
Come on, Neil.
Aren't y'all pumped about next week?
Really, I'm narrative.
What?
45 to 50 next week.
So whatever you guys want.
I think I'm more sure
Better.
that's
I am so
I
excited.
was
to not be with you.
Never put faith in
I am.
Warm up all the
I had to dress up as a skater class yesterday.
Oh, that movie's
I
amazing.
it's cold.
It's at Permanent. It's at Permanent House. So you have to dress like you're gonna work there.
Don't let don't let the spoon fall in.
Yeah, you know, there's 5 at the
Who has the dip chips?
like,
No.
there's no like.
I just like Dan and his sister. You're gonna be like
I take butter.
You spilled.
Me too. I don't know. My grade's like 85, but I got 60%. So if I do anything better than 60%, it's gonna boost my grade up to grade.
Hey, man. English guy.
Remember,
Did you find it?
so if you get anything better than a 60%, yeah, we're getting the D's, some of the D's ones.
I actually like DDs.
I don't understand that. How does it come?
No, like,
What are we doing?
I haven't learned.
Check over.
I probably nailed.
You won't either. 2 tries there.
Your class was
Actually,
so awful.
I have learned a little bit on how to instruct this.
Really?
Have you?
We have. We've taken the last like 2 weeks to like instruct it. We're not actually making it.
Yeah. And now we're can't get any farther, so we just like
Since it's not gonna be
and we've done like nothing to try
we don't have to spend all the try on it.
Are you?
So it's only 6 pages,
Yeah.
and you guys get a
When do you have your next year?
Last year.
Aren't you glad you only had a week though? Because now you have nothing to do for the last 2 weeks.
It makes sense.
No.
Been running it
No,
on?
it's
Cool.
not very
Guys,
sad.
they're dying.
Play outside. Who
Oh,
got
we noticed the Pepsi's missing.
There's no other. This is all.
Why?
Yeah.
Why should I get that Coke?
Inside?
She doesn't like, it makes us
I
We
remember
watched
time you
all of
died.
it, Beth, and college.
Do Diet Coke. and all.
Died? I didn't actually have one.
That used to-
Because he drops the thing, right? He drops the minus sign.
If you're sitting at a, you're sitting at an A minus, you're at an A.
I wish JoJo would have peppered me with that water.
If you're sitting at a B plus, you got a B plus.
He didn't put my 12 and 13 in yet.
That's the same.
I know, yeah. I think he has a grade. I think he might have a grade. He didn't have my grade though. It's like 7. Those personal testing that he didn't have my
Wait
grade.
till it dries up.
12 and 13.
You're not hard.
Right.
Oh, you can't
I
tell
was
two
just-
He's
seasons.
like Jacob, like you said. But yeah, I was the first one.
You have Jackson, you were playing it. Even Dylan said it. He said you.
Today he gives me back.
Were you lying about calling it then? Why'd you do that?
No,
And then there was a bunch of railroad tracks, and there's one lane of cars. And there's 10 lines.
Two?
And there's like 12 lanes of railroads. Should have had like.
Did you get work by yourself again in County?
Give me a full car.
What?
You gonna be laundry today?
Are you guys done?
No.
I just have my study guide.
Surprised you don't have a car. Surprised you don't have a car.
I don't know, the part of emotions problem.
Just that.
Four of them, yeah. Studying.
He said his mom's car though. That's what he said last time.
I have to do my study guide and my test, and I'm done for the try. I've timed that like
I was wondering why.
Major, you done the counting, AJ?
All of Josh and Butler saying.
Yeah.
Nick Wolf. Nick Wolf. Are you saying Nick could do anything? Is that what you're saying, AJ?
We wish the whole
We got Friday or Tuesday or whatever.
Yeah, he can do something.
Mina going to bed.
That was so funny.
I'm letting the stuff I was doing.
Did you file everything too or no? Really?
No, I didn't file it.
Just say, you used to have a file stuff.
Too, but I life insurance class. I ate a ton of food.
I feel like I'm not him.
I'm like,
Computer stuff, it would
Are
be
you
wrong.
eating stuff?
That's like my your partner, right? Jake?
No.
I think somebody help me clean this when it's done.
You won't go wrong. You just
Oh,
wanna
eat
go
the
quick and
food.
fast.
We have.
Gold knows his
I have a
doing.
research paper to write kind of next hour.
I stayed.
I really want to. I could trust myself.
Hello?
I stayed last time, but I'm home.
Depending on what time this gets done.
I studied clean last time, but I
I'm
called
like
about
really
it.
good memory too, though.
I have Mosher.
This is
Don't
weird
care.
character.
I have
The lights go up and then just fall out now. It's like a little purple out.
Oh, cool.
And then this fall red. I'm like,
That's a good gig to have. Very cool. 1995.
So mad at me.
I'll take you
I mean, obviously.
Number key, keep that.
Do it. I dare you.
It's hard for us.
Never know when you guys are gonna be your last.
Because then,
Right? You read that email?
Yes.
like in like middle school, you make speaking. I just put that just like number games. Get bad.
Today's is good.
I don't know, I didn't file.
not just.
No, today especially.
What is?
I should have had dessert.
Let me call you back. I get
Did you read that email?
and then I can.
Oh, no, it was at work. I'm gonna go break some.
What do you want? You got this. I think one and one got.
Hey, Patrick. Go tell Corey that.
I'm a bottom part. I'm a bottom. I don't think I'm gonna break something though. Should like not eaten yesterday. I should have like starved myself.
Yeah.
Yes, when we have a playoff game tonight.
I got it.
I just can't.
I'm getting pretty close. I'm 6 close to the pack. The pack's are 8, so.
Actually, you can buy some.
I'm so sick.
It's not the same. It's still a hot dog. You don't need
He
it.
is. I built him at section. He got a concussion the next game though. He was out for like 3 weeks. He's really good at that. He had like
Who was?
DL. Good golf too.
Yeah, because you know, I don't even see Mike before he leaves. See the mountain. I got you on business.
That was fine.
Which older do I?
My hair's up in the
We should
front.
make it more.
That's
My
white.
friend that-
That's not mine.
My friend that made this deal.
Hey, you should probably find
He's a scratch golfer. My friend that made this deal.
Well, no, he went to prison too.
What a guy.
You're right here. You would.
My role model.
And you wouldn't
The guy who
Used to be a pro.
No, it's more stable welfare here.
Like what kind of problem? Like playing defense or like
You have to be able to swing out and scratch.
unless you're taking.
You have to be able to
Like, did you hear that? Is it Tanner or saying or something out grade?
Billy,
Yeah,
every time we have this here,
Can I see this, Blake?
Dude, Nathan was going to beat that too. Boys, no, we gotta go.
Touching you with this.
Nathan was on like his 6th ball or something.
Oh, you touched me. Release it. I don't know. Patrick. Hit me. Grab me.
I gotta clean this up. Y'all gotta help me clean this up.
Grab your function spot.
I want to see if you beat it.
No, I'm not doing another one of these.
Battle for the battle between Holly and Brown.
Every meet.
Yeah, we should have something to
One a week? Oh my gosh.
I'll make
Wesley, why would you want to make something if you're gonna have worse than you?
No, we play in every meet.
So like, what?
They're gonna keep it.
No, we're gonna keep it.
Never make hot dogs.
Yeah, we
They
are.
graduate out.
Let people start kicking in. Everybody will pick it.
They graduated with 5 spots.
Yeah, you guys graduated off the
Well, no, we graduated our 6th spot.
Yeah, but how close you
I just can't do it once a week.
We beat them once, and we lost to them by like 5 strokes, like every time.
So what's the rest of the
And
screen?
in one of the meets, we were up by 4 strokes
You should take it.
until their last golfer had to come in and
Elijah?
shoot 1 under to beat us. It's like, oh, there's no chance. It's like there's 3 spots. There's no chance he shoots 1 under. And we're like celebrating and like chest bumping out on the green. And then the kid comes in with 1 under and he beats us.
Well, you know that room up there, the resource room?
No, Drew's game.
You kick the
More.
He pulled a call in at like
Yes, well,
Wait,
well,
wait,
well,
wait.
This high school picture.
Okay.
Yeah, but I think Bryce goes out of the guy right here.
I wasn't trying.
No, that's good. You weren't like you're bad, but he does bad.
Alright.
I think
Literally 5, there's like 7 more hot dogs over here. Come on, let's do
Because
this.
I think you get it's better than you, but they're so fitty.
I am disappointed in y'all. Y'all are letting hot dogs go waste.
We'll bring some more.
You asked me to buy more.
like if you're gonna be an athlete, you gotta like there's no point being in it.
Depends.
Hey.
I'm not behind it. People see the quick results and everything.
There's
I got some time.
We did that, she's still better.
There's ambassadors left.
Yeah.
Let's see.
I just want to tell you that. Okay, you look talking about how like the numbers flat numbers by
No, I'm in a box and then it's after.
It's in our section.
Cold. You should have been over there.
Helmet's battery.
What?
No,
You know what?
Oh my gosh.
I wasn't that
Yeah.
Pretty simple.
But that means they get in trouble tomorrow when they find out.
Make sure you catch please pick up all your trash. I can't tolerate it.
Do you have a freshman class after this week?
Don't ask me, I don't know what this means. See, you know what this means. I know. You know what it means though? Physics chemistry.
I
Physics chemistry.
am very hard for myself.
Neither have I just someone else.
What does it mean?
David, I have worked very hard
We just
to
need
get
to
myself to
like,
keep that
Freshman gets done, see Colin?
Physics is so bad. What's that?
Y'all didn't let freshmen.
You know, I was freaking pronunciation, like, make use of this. Like,
We really didn't tell him no. It was just Mark down the bottom. She's brilliant.
I kind of like all the like yesterday.
so we get out. Chemistry.
No, because there's kids in our class that are like loud and obnoxious, and she doesn't do anything to try to shut them up. So you can't even hear her when she's no.
I'm not gonna
Yeah.
She's not like even after it's like super easy. It's like, hey, will you teach me? It's around you.
Exactly.
Just like uncontrolled text.
Labs are.
That would work. But she doesn't give you how to do anything. It's like, here, here's the swimming.
Where's Natalie?
That's the fun of it.
I'm still socializing.
But yeah,
Well, I
I
got
got your own
start
treatment, but here's the parameters. Use this,
I gotta start class.
You can't combine these two together.
No, physics
Okay.
was totally different. Physics was totally different. It's like a whole brand new
I'm gonna.
Yeah.
Marvin, what do you got next down?
I stayed last time. I stayed last time.
Open hour after this.
Screw you, all of you people.
hour.
Screw you all.
Class.
People
But the only one that has open hour.
I
No,
know.
Colin, that's what I'm
The second time.
They should do something.
already gone. Probably already
I'm done
gone.
with yeah.
Patrick, good job.
Actually,
Good. I told you.
I'm not sure you recommend it.
That wasn't even that hard.
Okay, she wants to dump this and do her water bottle. I don't know where it is. Physics.
You didn't even see that. Super big markers on your car. You did? I saw it. I didn't know if they bought them.
You ever told them I have an open hour?
Why do I need to?
Joe, you missed out.
You told them I had an open hour?
No. I just said you have an open arm. You can play and help motivate my friend.
Thank you. They said we're gonna drink. I'm
I know.
Let's take it in a roll.
Oh, that's your water bottle. Where's my water bottle? Jake, where's my water
I
bottle?
was yelling at him last night.
Alright, I'm just gonna go on them
I'm
and.
gonna go leave.
Help
I
was
didn't
a
see
bad
you. I didn't see you.
Where's my water bottle?
Thank you, Morris.
Thank you, Morris.
Thank you, Morris.
Dang it.
Where else?
Whose chips are these? My table?
Here, what I mean.
I really did.
They're not despising it.
Nobody here has an open arm?
Morris.
This one.
We have a workshop today, or here to go over more.
Sorry.
Sorry.
I didn't realize
Why
you
did you
used
stay
Morris.
to leave?
I
You
just.
never used the crock
Oh
pot
my
before.
god.
You didn't realize it was
It's okay, it doesn't matter in vacation.
Josie, you need to find a more intelligent name.
I realize that. I'm gonna take this.
These are
You can go.
smart.
You never.
Oh,
When we,
even though he got freaking like 30 something.
At least the eating part's
You're gonna get like a
What do
30.
you do?
What did he do? Yeah, he picked up the
Theory,
green,
theory, you did it on purpose.
or he picked up the white and then put it on. I mean, he didn't realize how pop.
My lashes on here.
He got 32 and he's just good.
They can pick that up everybody.
I don't know if I'm taking it or not. Heats up.
I think I will. The worst test I had was 72%.
Mine was a 78. So I mean, it's not horrible. I'm
Are you really gonna get me one or you just saying that?
Yeah.
It's a lot of it in your crock pot.
I'll borrow one from my
But he
house.
doesn't have my
I am full.
Something Americans never say.
Really cheap dog. Really cheap dog.
Get up your garbage.
I know. Oh gosh. Oh, we need that back.
I can't believe my crock pot broke, honestly.
Darn, you just wrapped it.
At least
Neither could I. My wife said, go to school, said, if you break my crock pot, don't break it. That was the very words today.
Well, you didn't break. I am so break so sorry.
Go.
Like
How's it going?
I went to
Going
do
pretty
the
good.
same. I just slid right out.
What?
I'm just kidding. Danny, you are an idiot.
Oh, good.
Oh! God, what happened?
I don't know. I don't care.
I'm not gonna be here. I don't care.
Hey, we have open arm.
Yeah, he's.
I'm not gonna be here next
Just
week.
like Conway, Patrick, and Colin.
So you're going to college already in senior year?
He is.
Oh, it's post-secondary, that way. You're going to Ed State, what? DL or Diener?
Deal.
Yeller?
He's going for out of line.
Oh, Yeller.
What they say about the Walker
So you're not going to be seeing Morris at all, huh?
No.
I'll be here for like first and second hour. You know, it's breaking out of my time. Excited?
I'm so sick of this.
So how'd you guys go with your fight? Why?
She made him cry.
I wasn't laughing, I was like, what? I don't like abusive people. And I really don't like abusive people. Like,
It's not going too good.
like, I just can't do it. I
I
can't.
don't consider it.
If someone just comes up to me, boom, what's wrong with you? And then it's like, oh, I still love her. And I'm like, get away from me. You're psycho. That's who I am. You're not psycho though.
Oh, shit. Yeah, she is. But look at her. Look at her. She's gonna
I like her.
Oh, I
eyes.
didn't.
What's
I'll
the
show you.
bad?
I'm scared.
I studied for it.
None of us studied for it.
I've always liked her.
Yeah, I think that's tomorrow. I guess I've none of the study for it. No.
Thanks for the invite.
Grab
Thanks for the invite to your party.
You're welcome.
Hey, Ryan.
Put all the food on my desk. Oh, jeez, people. Sauce on here. You're killing me.
Yeah, that one.
Can I switch
No,
this
no.
out?
Oh, yeah, by the way, we never got to the room.
This part's open.
I hope so.
We never got to the room.
Take these four down. Yeah, and this goes, this stuff. They say it's fine. You don't have to take the whole thing. Just take the side part.
It's blanket.
Yeah, you can lift. Might get that one. No, they're all gone.
Did you drink pop?
They didn't, I didn't buy it, they spent like $200.
Did they really?
You just drink
They bought it all.
Was it gone?
Yeah.
No,
So I suppose it was peaceful for installing?
where's the basket, what a basket was.
Jeez, how much wine do you eat?
We watched the movie.
Meatballs.
We're watching
You want one?
I guess that's all missing physics too. Maybe. I don't even think we did that.
I
not?
protest.
Basket.
Tell you what.
Take a bag of chips. Huh? Hey, come here and take a bag of chips, seriously.
You already took a bag.
I like the map.
Hey,
Excuse me for this announcement, the CNA students for third try that Mrs.
hey, y'all can have
Oxley
some
told us
chips
today,
if you want some
please
chips.
come to the office at this time. CNA students, please come to the office at this time.
No, you can't, just grab a little plate. Plate.
I have some Diet Coke,
No.
since that's open.
So if you would like some chips, you can grab a plate and some chips, I don't care.
Morris.
I really have to go. Because I have to CNA next time. Oh.
Better hurry, we got a quiz. We can get rid of
Oh my god, it is today.
it. Tell them.
Oh, I failed this quiz.
Told you we had a
Can we not take it?
quiz.
Because you did pretty good on it.
Yeah, I
I
did too.
don't get them.
We had to take this quiz.
Yeah,
You have to.
I pay
Yeah.
for
I'm counting them both.
What?
I'm just gonna replace the lower.
Yeah, I'm taking a hot dog. What is it to you?
I'm counting it twice.
There's no more left.
You said you count the highest one.
Oh, if you do good.
I'm gonna do terrible. Me too.
Oh, you guys tested it?
I thought it was tomorrow.
Yes.
You wanna take it tomorrow?
Yeah.
Oh,
Yeah.
do it. I got it. Now.
No.
Hey, we'll do a vote. We'll be democratic about this thing.
I'm gonna be the only one.
Raise your hand if you wanna take it tomorrow. I guess that's.
No, thank you.
Universal.
Can I take it today then?
Yeah, at the end.
That's a fair question.
That's that. Yeah, at the end you can. All right, take out your homework from last night. Your 60 problems. I gotta go check that.
64.
Problems.
Yeah, right?
Who gives 60 problems?
This guy right there.
Raise your hand if you for sure got it done.
You can decide it, but I'm not.
What? All right, raise your hand if you for sure got it done. Look at that, Knudsen.
I got it downloaded. They're lying.
Well, I'm gonna find.
You don't even know what you're talking about.
What are you guys talking about?
The homework's coming.
I thought you said we had
Homework. 60. You got that
I
done.
thought, yeah, but you said we had to do that on 27.
Except for like.
You don't do
Joe. Want some more?
27.
You have a whole bag. Can I have a piece?
29.
I got it. I just need to
Then I'm not.
I'm not even. I told you it's so
I
got it
yesterday.
Can I borrow it? I got it yesterday. There's that many left.
I love you.
Oh my god. Third hour we sat there talking and eating breakfast. Very long. Sure. They want this, I gotta do it on mine.
Oh, you did go.
But I did. Oh, they're corn.
Yeah, 40.
Well, I'd be fun.
Seriously, I don't care if you go eat chips. Just
We grab the bag. Don't worry.
What about a drink?
no.
grab the whole bag.
It's mine.
I won't grab the whole thing.
You don't drink pop, Morris.
And
Liar.
I was done yesterday, and then I started back today, and I'll stop tomorrow.
That's not how it works.
What should I do with these? Just throw them off?
I was so confused.
Anybody want a dog?
Yeah.
No, I was kidding about when I wanted.
If you
Zig, we
want a
got
hot dog, run up there right now, and he'll serve it to you real quick. Grab a bun and a dog.
I was confused.
Say you should grab me one.
I did terrible.
I thought you just said you were just kidding about.
I know, but I don't want this orange. So I'll probably get it.
I won't be sure.
Did you have to go
Hey,
to the
Ryan, do you have
CNA
your
thing?
homework?
No, I did not understand it.
Okay, make sure you
It
do
was
it.
hard.
There's a bun there, Gene.
There's a bun. I want a bun.
Mine wasn't here yesterday.
So I'm thinking, okay.
That's why I didn't use pen,
He likes
because
the
he was here
wiener.
for the
He
meeting.
likes the wiener flame.
And he's done.
I was at
As long as he was
That theory doesn't work.
That's where you're gonna go. And then,
I have two more.
and then, no, he doesn't.
What's up with this bun?
Man's got it. Alex has got it. So everybody has to have their homework today.
I have it done, I
Ryan.
just, they're not right.
I mean, it's so fast.
Which
The
one?
one person that probably should have had his homework done right.
You can
doesn't
just
have
unlock
it
mine.
done. Joe has it done.
But that's what he was.
Is it an apocalypse?
Probably not 100% completed,
You
but
hear your
most of
Vincent,
them I
like
got.
just said you got it done. Shut
No.
up.
He doesn't need it done.
Not all of them are
You need
done.
these.
Oh, whoa, a little sketch now. What happened last 20?
Joe, ketchup. No, there's
I know that's what I said, Doc. I didn't
There you go.
have to do that.
There's no ketchup.
20 out of 60.
Dang it.
Is that ketchup?
No.
Yeah, there's ketchup.
Where?
Alex, did you do your homework?
Good job.
I bet.
I don't see no
Show me
ketchup.
as soon as it turns out.
Morris, can I please have a piece of licorice?
Don't tell me you don't understand if you don't come in for a show.
Ketchup. Yeah, well, I'm gonna put French fries on.
That are fractured.
Not really.
You know,
I did, I didn't understand.
I responded, you only emailed me one time, you didn't respond back.
Yeah, because there was like,
Straight up.
that's not the same. So you can't do it.
2016 is what?
Oh, I thought you meant just like it'd be the same. So then you
Only first?
Those are like soggy.
What was the
I think.
They're like squishy. I think that's what a wiener would do.
What about you?
You're thinking bad.
Good job. That's awesome.
Where's the
Have a
ketchup?
seat. No. Feels no.
Oh, I feel like I'm your dog.
Sit down.
Sit, Ubu, sit.
It was weird. Like the fraction one?
I don't know if I did most of them right. Besides, I put them in the right form.
Give me a rocker.
I was looking at pretzels and barbecue chips yesterday.
You guys love that fucking mom.
Now when you eat them all day, you have to work for it.
They're good.
How's your coffee?
I'm just doing KP.
Hey now.
You guys are terrible.
Alright.
Now you mean
Yeah,
like
that's
my
all
passing your
We need to get ready for this tomorrow, so listen. Okay, you got it?
Today's review.
Today's review.
Okay.
I'm ready.
No, you don't get to leave.
I want to be
Yeah.
which obviously is not myself.
No, I don't need that.
Alright.
Well,
So,
Yeah, it's
What you got?
I'm so mad because the worksheet we're gonna go over really ticks me off.
Why?
Because I had the answer key and I deleted it.
That's horrible.
I got so mad this morning because I had my answer key because the program, it makes it and I saved it and then my computer crashed and it lost the answer key.
I thought you said you could do it in like 30 minutes or 15 minutes.
I can, I'll just do it right here. I didn't until today, I'll quit tomorrow.
I'll quit
That's
tomorrow.
not how
You wanna see
something
me
works.
chug this in like 5 seconds?
Yeah.
Do it.
Yes.
Morris,
Here we go. Just kidding.
Zach,
You know, if I chug this, and you know how
Really?
fast I'd be going around and around? I'd be like the squirrel on Over the Hedge, where the earth went into slow motion.
Yeah. Oh yeah.
Okay.
I knew that would happen.
Yeah, I had it with her wife.
Chug. No.
Actually, I hate Pepsi. Does anybody want this?
Not after you know.
Don't give it to him.
Just give everything to say. That's
Good, Cameron. Cameron never gets anything.
I'll take it for next star. We'll share next star.
If I spit a loogie in it, would you still drink it?
No.
Give me a straight.
I'm asking. If I spit a loogie in this, would you still drink it?
No.
Maybe.
Why not? It's just a little bit of snot.
If you paid me.
Question. Can you pour some in there before you do that?
I'm not gonna spit a loogie in it. But I
Well,
just
I'm
drink
ice, so it'll be
it. I just
cold.
drink
And
it.
then he yelled.
No?
Can I have one in a phone?
I don't know. I crossed out with like the slimy texture.
You've had too much pop, dude.
No.
Look, you got Twix, Mountain Dew. You're not having any of this.
Zach,
You know what kicks my chair?
hey, you
had like
Oh crap! I don't even pop. Usually you have like two.
Okay. That was so rude. It was the meanest I've ever said that.
Oh, okay, okay.
Oh,
I'll mix it
I'm
in.
gonna get so many cavities.
I'll mix it in.
I don't get cavities.
Yeah, okay.
Same here. I never get
I don't get cavities. That's what they've done. I'm gonna have the best soup ever. You guys have superpower. Hey guys, Stop that, guys.
Hey, can I have the Pepsi?
The homework he doesn't have.
You got no move. No.
Yeah, I want the Pepsi then.
If I drink,
I wasn't here,
Hey, you don't do shit. I don't know. I was gonna give it to you.
No.
All right, here we go. Get this out. You gotta have the homework out. Let's go. Okay, we're gonna work it out. See how we did? I wish I had the stinking answers. All right, raise your hand if you can confidently tell me the answer to the first one. Raise your hand. Raise your hand. What? Yeah, let me get it again. What was it? Actually, it's up there.
It's 2x.
2 absolute value of x, 6th root of 3y to the 5th, z to the 4th. The absolute values have to be around the x because it's an even root, and anything that comes out, if it's an odd result, needs absolute values around it. So mad that I can't have this answer. Okay, next one, 7th root of 256. Who thinks they have this one? Okay, go ahead, Nick. Shh, girls.
2p 7 q
2p to the 7th root of
2q
2q.
r
And should there be absolute values? Why not?
7 plus not even.
Huh?
There's 8 feet to 7 foot.
He said that, I just didn't write it. What's left on the inside? 2p, q to the 5th, r to the 3rd. Do we need absolute values? No, why not? Because it's a cube root, or an odd root. Odd roots you definitely never need. You do not need absolute values anytime you do an odd root. Only when you do an even root and the result is odd on the outside. That's the only time you need absolute values. Even root, odd result on the outside. What about the next one? I got this one. 4 absolute value of r root 2. I can do these now. Or actually, the next one I can't.
I'll do it.
Alright, just the number, because I don't have a calculator in front of me. I need to sit. I'm really tired.
How much coffee did you drink today?
Huh?
Chili dogs.
There's nothing. No, just the stuff. Let's see what we did.
I know.
I'll call. Thank you guys. You guys are good. This is mine, but it doesn't work. It's broken.
I'm just happy Kenny broke it.
Okay. What about the fourth root of 324? Fourth root of 324. Come on. Talk to me.
3
3
x 5 absolute value.
x, y, need absolute values. Fourth root, what goes on the inside? Huh? Is it 4x? 4x squared. You guys agree? Okay, we good on that one? All right, next one, I can do this one in my head. This one's gonna be 3xy, absolute value around the xy, square root of 2. Okay, next one, I can even do. It will be 2u, I don't. Fifth root of 2u squared v. Yes, no?
Yeah.
In agreement? It's kind of a pain without my answer, Kenny. Yes. I want to make sure you're good. Some of that stuff will go fast. This first page and a half. Once I get to the next page, I'll be able to fly. It's these dumb big roots. All right, next one. 3 cube root of 27 times 2, right? So what would you bring out? Cube root of 27 is what? 3. And a lot of you probably took it down to 3 3s. Okay? But you could just start doing it in your hands. If you recognize 27 is 3 3s, you could go ahead and just say cube root of 27 is 3. Bring it out. So you have 9. It'd be 9 cube root of 2. There's the answer. Next one, it'd be 6xy absolute value times the square root of 2. Yes? No? Okay, let me know. Can I erase?
What was
Yeah, not
that?
yet.
Can I go?
No.
Yeah.
Don't listen.
Don't listen to you.
What?
What?
Where? When? How? Sometimes why?
I give up. It's not writing.
All right, number 9. This one right here would be, let's see, it'd be 8 times 4 to 8 cube root of 4. Next one would be negative 8x, absolute value of x, square root of 2y. Okay? Next one would be negative 12 root 2. Alright, how many are good so far? Alright, so tomorrow on the test, there'll be a section of that. Where you just got to simplify, straight up just simplify. Then there's going to be a section where you have to do operations, add, subtract, multiply, divide. And there's absolutely be extra credit. So if you remember to, but if you choose to do it and you do it wrong, I will take off. So if you're going to do it, be confident.
Confidence, not.
The only thing you have to do on absolute values, here's how you remember. If you're doing an even root of a power and it has an odd result. Even root of a power with an odd result. Okay? Even root of a power with an odd result. So if you're doing an even root and whatever comes out, the variable, if it comes out and it has an odd result, like x to first divided to third, you need absolute values. Even root of a power with an odd result, absolute values. Even root of a power with an odd result is the only time you're going to use absolute values. Say it with me. Even root of a power with an odd result. There's no other time. Say it. Thank you. All right. All right, the next part, this next section will take a little bit of time too, but after that, probably most of the questions are here. All right, so when I do this, first of all, these cancel. How many saw that right away? Guys, look for the obvious. Okay, those just cancel right off the bat. So now it's just down to a simplifying problem. 243, what does that reduce to? What does that simplify to? Fourth root of 81 times 3. 81 is really how many 3s? 4. Because it's 9 times 9. So you can take a 3 out, so it's -6, fourth root of 3. How many got that one? Excellent. This right there, watch this. Look. Bloop, bloop. Now, for the Ryan, you weren't here yesterday. You just simplify each one, and then when they have same index and same radicand, you just treat them like variables. Okay?
Why do you multiply under the radical sign? Like you go from 243 to 81 times 3.
Because I'm just trying to factor it down. So fourth root, and then 81 is really 9 times 9 times 3. This has still got to multiply together to give you 243 because I can't change it. And then it's -2 times the fourth root of 3 times 3, which is at 9. Another 3 times 3, which is at 9. Another 3, because now we're looking for groups of 4. That's the only reason we're doing this. We're factoring it so we can see if there's a group of 4.
Okay.
It's the only reason we're doing that. Then this right here would be -2 times the cube root of 81, which would be is 27 times 3, 81. I can just do 9 times 9 again. -2 times the cube root of 3 times 3 times 3 times 3. How many 3's do you have to have in your group? 3. So what goes out? 3. So it'd be -6 cube root of 3. How many of you are getting these? Okay? It takes. I don't disagree with you that it takes a little bit of time on the simplifying ones. Now, once you got down to the rational exponent part, 40 through 60, that should have been fast if you knew what you were doing. Okay? This right here, watch. These have the same radicand, same index. Can we add them? So it's -√18 plus 2 root 18. 1 root 18. So that's root 18 plus 2 root 2. But now we can simplify it further. Does root 18 go further?
Yeah.
That's a 9 times 2. What's the square root of 9? So that's 3 root 2 plus 2 root 2. What's the final answer? 5 root 2. So as long as they have the same index and same radicand, you can add them. These 2 root 12s just cancel. So then you got -√24, which is 6 times 4, which is 2 times 3 times 2 times 2. How many 2's do you need to have in a group to go out? It's a square, it's a 2, so you take a 2 out, so it's -2√6. And how much work you show is kind of up to you. Okay? So that's adding and subtracting. You have to have same index, same radicand. Same index, same radicand. Okay? Multiply. You just multiply the numbers out in front. So you have -3 times 1 is -3. Here's what I would do. Is that really makes sense to multiply 15 times 3? Why? Because you need to start simplifying it anyway. So 15 times 3, what I would actually do is change the 15 into a what? 5 times 3. And then you have this 3 there. So there's your 15 times 3. You have a group of 2. So what can you take out? So -9 root 5. Okay? Does that make sense? Now some of you might have took 15 times 3 and made it 45, but then you realize, well gosh, I got to simplify it 45, so you're just going to refactor it down. So I would encourage you, don't multiply those numbers underneath the root, just start factoring them so you can look for your groups of 2, 3, or 4, depending on what kind of root it is. This will be, watch, you can make this root 12, but is it a benefit to do that? No, because you're just probably going to go back right to what? 6 times 2, or 4 times 3, depending on what you want to do. Do we have a group of 2? So what's the answer? 2 root 3. All right, we did this yesterday. This is just doing what? Distributing. So we're going to distribute. So I'm going to go root 15 times root 3. It's totally legal to multiply roots. Okay, adding and subtracting, you have to have same index, same radicand. And treat them like terms. Treat them like x's and y's. But multiplying, you just multiply what's underneath them. So I'm going to multiply the 15 and 3, but I'm going to start factoring it. So what's 15 factor to? 5 times 3, then you have that 3 there. Minus 15 times 10, I'm going to go 5 times 3 and 5 times 2. Does everybody see what I did? Now, Do I have a group of 2 over here? So that'd be 3 root what? Minus. What about here? 5 root 6. Can I add these together? Why not? Say, they don't have same radicand, so that's your answer. Here, I went over this yesterday. Let's see if anybody paid attention. Anybody tell me what that would be?
6.
So it's going to be -5. You have a 1 there, so 1 times -5 is -5. All right, this is what Alex gets it. He listen. Root 6 times root 6, what happens when you multiply root by itself? It eliminates the root because you're creating the pair, and it's automatically a what? Now, if you put, watch, if you go 6 times 6 and say 36, are you still going to get to the 6?
Yeah.
Yeah, you just created an extra what? Step. Is it a big deal? No, you're still going to get it right. It just made more work for you. So hopefully you'll be able to see a root times a root just cancels it, so it's -5 times 6. It does not become -56. You don't know how many times I've seen that. You're like, ooh, all right, I make a new number. Those are multiplied, okay? All right, then this will be +5 root 6. So we're going to have -30 plus 5 root 6. But I guarantee you somebody's going to put -56 by accident. And it's not because you meant to, it's just going to be because you forgot that it's multiplication for just a split moment. You forgot. Be careful. Hopefully it won't make that mistake. What do you got to do here? Distribute. FOIL. All right? Alex just told you what to do. -5 root 2 times root 2. What's going to happen to the root 2's? Cancel, and you're just going to be left with a what? A 2. -5 root 2 times -4. How about plus 20 root 2? -2 times root 2. Just foiling. -2 times -4. I'll say, do we have any like terms? What is this going to be? What's -10 plus 8? -2. So those slash and burn. Are these like terms? Plus 18 root 2. Got it? No, you won't. I'll just give you 61. Root 2 times root 2. Just kidding, I'm not going to give you 61. Root 2 times root 2. 2. Plus 2 root 2. Plus root 2. Plus 2. What do we end up with? 4 plus 3 root 2. All right, now we're going to get to the one thing I didn't get time to teach yesterday here in a minute.